Hello folks, greetings. Welcome to this introduction to computer programming class. The goal of this class is for you to understand how computer programs work. Why do we need, there's something called as high level language, why do we need that? And understand the overall process of programming. So the outline of this class is we start with defining what programming is. Then we figure out how a program works under the hood in the computer. We talk about operating system and why operating systems are important in a computer. Then we try to understand the number system that's used by the computer. Then we go down this journey of how instructions are fed into the computer. We start with raw machine instructions, then assembly instructions, and then we go down to high level languages. And finally, we look at how does programmers program, what is the programming process. Okay. So first, let's think about what is computer programming. Okay. So, computer programming is a way to instruct the computer. And what does computer do? Computers solve computing problems. Okay, and so it makes the user's life easy by solving all sorts of computing problems. So if you take a computer, it can simply do some basic arithmetic and basic comparison of numbers. Whereas for the user, there may be many more complex computing problems you may have, right? Simplest example is in the storefront. They scan all the articles you bought with the barcode scanner, and then the computer automatically totals the list out and then prints you the bill, right? Now there are a few things that the computer in a storefront does. It obviously applies taxes, applies any discount, includes any coupons and stuff. So all of these things can be done manually, but when the store is very busy, it makes very easy. The human beings can make some mistakes, whereas in the computer, the bill gets generated easily, right? Now go down to a problem where you want to measure the, let's say the radiation intensity of a distant star. Now that involves a lot of calculations. Now in both the cases, you do need these computer programmed instructions, which takes the simple arithmetic that the computer can do and makes it into something more complex, right? The way we do it, the way we take simple algebra, and then we go and do some problems in calculus, right? It's the same way that the computers can do, but it cannot do it on its own. It needs to be fed as instructions by a programmer. Okay. Now, because the computers are machines, computers cannot figure out things on their own, and therefore when you feed in the instructions have to be mathematically precise, right? If you make any small mistakes, then the computer will also make the mistake. And therefore, it becomes very scientific, and that's why it is a science. On the other hand, if there is a computing problem, the way a programmer approaches to solve it, given the constraints of the machine, right? The machine may have less memory, it may the user may need the answer much faster than what the machine can give. Now, in those cases, programmers innovate a lot. They become very creative in solving the problem, and that's why it becomes an art. Okay, so computer programming is both an art and a science. So we covered that. We take simple instructions, simple calculations, and make complex ones. So the one other thing that I want to mention very clearly here is that computers, they seem to do a lot of stuff, right? You can compose music using a computer. You can edit or you can watch videos. You can play games. You can communicate, use the social media. So it seems like computers are sometimes a communication device, sometimes it plays music, sometimes it plays video, it is an entertainment device, and sometimes it helps business, and sometimes it does calculations. So when we say computers only does computing, then how that can be, right? So that's what you need to be very clear. The instructions you feed into the computer and what the computer does internally is always mathematical calculations. But those mathematical calculations, the results of those mathematical calculations, can be converted into certain digital signals. And those signals may be in the form of a video, or it could be music, it could be something that you can pass over the network so that it gets to the other place and you can work with your social media application. So all the things that happens externally to the computer that's useful to the human beings internally is plain numbers and plain mathematics, right? So you got to keep that in mind. So the other thing that I would say is that you don't need to know advanced calculus to do computer programs, but you do need to have some basic understanding, basic mathematical skills, right? If you don't have that, then it's always easy to go and acquire it, but you got to remember that you got to have some very basic mathematical skills in order to start programming. Now, there are types of programs like statistical programs or scientific programs where you need more advanced mathematical knowledge, right? But for some of the fundamental programming, right, you don't need that much mathematical background. Okay, keep that in mind. Now, here are some examples of what your mathematical results get converted into something useful in the outside world, right? So when it comes to video, for example, all the computer does is it thinks in terms of dots and colors and frames, right? So when you take a video, it's multiple frames of 2D pictures that is shown at a very faster rate so that you can see a video, right? Same thing with the computer games, right? The computer generates the mathematical results, which gets converted into your LCD screen in the form of a 3D object. Now, this is a very advanced example where computers do, they do work with other electromechanical devices to actually create a physical change, right? We call that as control systems. So basically, in today's modern aircraft, especially fighters, the aircraft is built with a lot of instability because that's the way the pilot can maneuver the plane in positions that normally is not possible, right? So they put a thing called fly-by-wire system in the aircraft And this fly-by-wire system is a thing where even if the aircraft is unstable, this software program will keep it in a stable position, right? Um, and there again, you see that it's all mathematical formulas and mathematical calculations that happens inside the computer, which just gets translated into, controlling an aircraft. Okay. And this again, I explained that you can compose music, and a mathematical value represents things like note and pitch and everything. So that said, what type of instructions? What kind of instructions do you give to the computer? The first one, of course, is computing instructions. Then you can also ask the computer to take some logical decisions. You can ask it to compare different numbers and tell which is larger, which is lesser. And if it is larger, can you branch out and do something else? So those are some logical instructions you can give to the computer. And then ultimately you'll have to give some hardware instructions, transfer data from the disk to memory, right? Transfer information that's in memory to the LCD screen. So those kind of hardware instructions can also be given. Okay, so now that we know what computers are and how these computer programming works, it's nothing but a bunch of instructions, right? Now, one of the unique things in a computer is that it's unlike other machines. You can feed in a lot of instructions, and once you know that those instructions are correct and it's working, you can store them in a hard disk or a CD-ROM or somewhere. You can store those instructions, and once the instructions are stored, it's just amazing because you can keep rerunning those instructions thousands of times, right? And that's a great thing. So let's say that you wrote something, program to solve something that you usually do in the household, okay? And what happens is that once you have that program, then you can keep running it hundreds of times and get some very useful results, right? And that's unlike other machines. In other machines, maybe there's some little setup or something that you can do, but it's in computers you can actually write millions of instructions and store them and keep rerunning them again and again. Okay, so keep that in mind. So now let's say that there is one such instructions or software that is in the hard disk, right? And computers usually need these external storage devices where you store instructions and data, right? Now, as soon as you want to run this program, what really happens is the instructions and some of the data comes into the computer's memory, right? And the computer's memory is so crucial because everything has to go through the computer's memory first, okay? And one other thing that you will have to remember is that, not all data is already pre-stored, right? Sometimes you need to input the data, correct? So again, the storefront example that you do need to say what all items you're buying before the computer can add it up and add taxes and other things, right? So in your instructions, some of the instructions will not have the data there, but the instructions still need to tell the computer that, hey, you got to allocate this much memory for this type of data. And that's one important thing. Whenever you program, you will keep doing that, is that you will say that, hey, allocate this much space for this much input that's going to come in, and then take whatever is stored in that memory space for your calculations, right? So now comes the important part of your computer, is the input device. Okay, and input devices, and of course it could be a keyboard where you type in the data, but any form of data that can get into the computer. Computers can get data from even your audio mic, in your iPhones or any phone, your touch screen. You make some gestures on the touch screen that also gets into the computer. Data goes in because you're clicking in the mouse, right? A barcode reader can put in data. So any of these such devices where data can get into the computer, those are called as input devices. And most of the time these input devices fill in the data that your instructions have already said that, hey, this data is this much is allocated for this data that's going to come in from the input device, right? So both gets into memory, and now the computer needs to do the or execute the instructions. So here comes the central processing unit, CPU, and this is the main part of the computer. Okay, and in the CPU there are three parts. The one part is called as registers, and the one thing that you need to understand about CPU is that a single instruction gets into the CPU one at a time. So you get one instruction and then the next instruction and the next instruction, right? And each time there is an instruction, the instruction contains an operation like adding or subtracting or multiplying and some data. What are you adding and what are you subtracting, right? So the data first gets stored in these registers for just one instruction, right? So these registers are really temporary units of storage. As by the way, the memory is also temporary, right? If you switch off the computer, the memory will also be erased completely, right? That's why you need an external storage device. But these registers are temporary storage areas that you need for one instruction. Okay, so for example, if you want to add, you will say that, okay, let me put a number in one register and let me put number in another register, and then let me do some calculations, right? Now this register that I put the picture here is the actual Intel CPU's register. Okay, so the other important unit in the computer is called as the control unit. Okay, so this control unit, and by the way, this control unit also has a little clock, okay, which kind of controls how fast this control unit runs, right? Control unit's job is very simple. As soon as you say, hey, run this program, control unit looks at instructions, and every time it sees the instructions, so it actually goes and gets the instructions, and it will, if there is any data that comes along with the instructions, it goes to the registers, and then whatever calculation you want to do, it gets the help from the most important part of your CPU, which is the arithmetic and logic unit. Okay, the arithmetic and logic unit is where the calculations happen. But control unit is kind of the coordinator. It pulls instructions from everywhere. It pushes data to different places. It coordinates calculations that is done by the arithmetic and logic unit. And arithmetic and logic unit obviously needs to get some data from the registers to do the calculation. Now, when all of this is done, and so if one instruction comes in, the calculations happen, the control unit then pushes off the data, whatever the results that happen with one instruction, back to the memory, right? And so it goes back and forth, because for every instruction there will be some data coming in, some calculations happening, and then the data going back into memory. And usually what happens is the results of one instruction is fed into the next instruction, right? And that's why things go back and forth into memory. And at some point, the calculation is all done and the data has to be reflected. Then, the data goes to the output device, probably a LCD screen, but you can have any other output devices. Speakers are output devices, printer is an output device. So there could be any output device where the data goes in. So the next thing that we need to realize is that, if you look in the computer, there's CPU, there's memory, there's something called as BIOS, which is basic input and output system. Usually the computer manufacturer puts some software in a read-only device that will help you, even if there is, because a computer, when you buy it brand new, there's absolutely no software in it, right? So in order to enter something through the keyboard and see something through the monitor, they put some software in. Then there are storage devices. Then there are I/O devices. When I say I/O, it's input and output. That means there's keyboard, mouse, all kinds of devices. And all of this is called as hardware, right? So this hardware on its own cannot do anything. So even as soon as you switch on the computer, if you have just hardware, nothing can happen, right? So as soon as you switch on the computer, there needs to be some program or software which needs to run in the very beginning, okay? And then the software needs to do a lot of stuff. It needs to do some process management, okay? So when you actually use the computer, you do 4 or 5 things at the same time. You will be editing a document, you will be watching a video on the side, and then you'll also be downloading something, right? And if in modern computers, you sometimes have multiple CPUs, but in cases where if you have only one CPU, then there needs to be some software which kind of manages all these processes. For you, it looks like it's all running in parallel, but it needs to manage by letting the CPU use some instructions from one process and some instructions from another process. Then also your disk where you store, again, it's just plain storage device. So how do you organize the storage device? Where do you store data? How to keep it efficient? What happens when you try to store, there is a failure? There's some software that needs to manage all those things. Then for each device, if you see that devices are manufactured by many other organizations, right? And then technology changes, and even though your computer has never changed, technology keeps changing. So in those cases that you need special software to handle or drive those devices. Then even to do some basic work in the computer, you need some user interface, right? So if you take all of these processes, and for all of these you need software, you can't, every time you get a new computer or every time a new process is manufactured, you can't be writing software for it and then write other software that is actually useful for the users, right? So there is software that manages the hardware, and then there is software that is useful for the user. These are software that manages the hardware, right? So long before, people thought that, well, we need a standard software that can handle all the hardware issues and manage the hardware. And then if somebody want to write some program that is more useful for the user, they will have to probably use programs that is already written to handle the hardware, and then they only focus on what the user needs, right? And so what happens is that there's also one piece of software called API, or Application Programmers Interface, where the API is nothing but a bunch of software already written to handle anything in the hardware, right? So all of these pieces of software that manages the hardware is called as an operating system, okay? And this operating system is so important that every time you buy a computer, you buy the operating system along with it, right? You don't say that, hey, I'm just going to buy this Dell machine. You say that, hey, I'm buying a Dell Windows machine, or I'm buying Apple Mac OS system, right? And so Mac OS or Windows is the operating system. So when you're writing programs, obviously you can write programs that does process management and disk management and all of those things. Some of them write it, right? But when you're focusing on software that is useful to the user, you will probably be writing software where you're focusing on the user's requirements. But when you want to manage something in the hardware, when you want to write to a disk, for example, or when you want to calculate how much memory you have, for all of those things, you will be using software that is already written. Okay, so your program can call another program, and that program is the operating system. Okay, and so your other applications, and I put some examples here, like a music player or some accounting software or a web browser. All of those pieces of software is useful to the user, and all of that software is written on the operating system. And therefore, sometimes a software written for one operating system may not work in another operating system. Okay, so you will come to understand that once you start programming, but there are technologies to overcome it. There's like Java technology, where you can write software in for one operating system, and it is portable in another operating system, and they use a trick to do that, right? But always the biggest challenge for a programmer is that even if there is something like Java, you do have a market where there are some people who are using one operating system and another set of people who are using the other operating system, and their user interface, the graphical user interface, differs a lot. So when you write application, you got to write it in such a way that it works in those two systems, right? And the modern problem that we have, and I think in my profession I'm facing that probably the last 7 or 8 years, is that when I write some software, the software also need to work in a mobile device. And then the mobile device has very, very small screen size. How do I make my software work there, right? Because a lot of people use mobile devices. So, and then there's other kind of devices like iPads. So it's always a challenge to write software for all of those. But at least we don't have to write what the operating system already does. Okay, so when we write systems, we also need to have some knowledge of what the operating system is, and very important is that API, the application programmer interface, because that is, we need to understand that, we need to be familiar with that, because only when we use that, then we can write software which can run on that operating system. Okay, remember that.